First of all, I should say that I'm very glad to present the results of our work done in Stakheev Institute of Organic Chemistry. My report will be devoted to development of effective real-time based PCR approach for the detection and identification of toxigenic Fusarium fungi. The genus Fusarium was established about 200 years ago, and as you probably know, Fusarium species are among the most dangerous and widespread plant pathogenic fungi, with several species affecting important agricultural plants like maize, barley, wheat, and others. The contamination of Fusarium leads to significant economic losses, and as a result of grain quality decrease and yield decrease. Fusarium fungi are producers of wide range of mycotoxins hazardous to human and livestock health. And so continual monitoring of grains and its products for contamination of Fusarium fungi is desired and very important. Fusarium species are producers of wide range of mycotoxins, such as trichotoxins, dextroserpinol, T2 and H2 toxins, nilolinol, deoxynilolinol and its acylated derivatives, and aniatins, derazone, mononiformin, and others. Why we use the PCR in our work? First of all, PCR allows direct detection of pathogen based on specific DNA amplification. PCR has potential of latent infection detection, and PCR derives high specificity and sensitivity, and high speed of analysis, about 2 hours, 1/2 2 hours. There are some approaches to detection of PCR result. The classical approach is electrophoretic analysis, but it characterizes a high risk of contamination in working space by amplification process. The decision of this problem is fluorescence PCR, like flash analysis, fluorescence amplification by specific hybridization, and real-time PCR, detection of fluorescence during the amplification. Flash allows the detection of fluorescence after PCR termination without quantitative analysis, just forward data. And real-time PCR permits possibility of quantitative analysis. Flash PCR and real-time PCR based on 3 main principles: quenching fluorescence effect, polymerase exonuclease activity, and complementary DNA fragment interaction between DNA fragments. And here you can see the graphic of these principles. Specific DNA fragments, specific sites for primers, probe with fluorophore and quencher, and the probe. Subsequent steps of PCR. And amplification cycle finishing. There are some strategies for DNA marker development. The first strategy is using of DNA sites with known sequences retrieved from databases such as GenBank of National Center of Biotechnology Information for primer design. And another approach is use of marker produced by random amplification of DNA and subsequent sequencing of specific fragments. Wrapped markers, random amplification of polymorphic DNA. Experimental procedures include three main steps: probe preparation, PCR amplification, flash PCR or real-time PCR, and detection of results. In the case of flash PCR, is detection after termination of reaction, and in case of real-time PCR is detection of during the PCR. Here you can see the results of PCR with primer pairs specific to Fusarium graminearum. Is electrophoretic analysis. We used 7 species of Fusarium, Fusarium graminearum, Fusarium primorum. It's important to divide these 2 species because it's closely related species. Fusarium protochioides, Fusarium jacintum, Fusarium 4, and Fusarium venaxum. You can see that groups 1 to 4 is a specific DNA of Fusarium graminearum, and there are no any false positive reactions with other species of Fusarium. Internal control in this case represents a plasmid with specific fragments timed to inverted repeats for amplification of only 1 primer. And the next, here you can see the results of flash PCR with the same primer pair specific to Fusarium graminearum. And here you can see the specific high-specific reaction with this primer pair with only Fusarium graminearum DNA. We have developed some PCR-based systems for the detection and identification of Fusarium fungi. First is species-specific detection based on sequences of translation implementation gene for detection of 7 individual species of Fusarium. The second one is group-specific detection system for Fusarium fungi with similar profiles of mycotoxins potentially produced by 4 primer pairs. All species analyzed was divided into 4 main types, chemotypes. Trichotoxin A producers of deoxyribonucleic and HT and T2 toxins. Producers of trichotoxin type B, uvalenol and deoxynivalenol, Fusarium graminearum, Fusarium primorum, and Fusarium cerealis. Combined chemotype Fusarium 4 can produce both A and B trichotoxin toxins and trichotoxin non-producing species, such as Fusarium vivinaxum, Fusarium fungioides, Fusarium pterolosum, and Fusarium trichincum. And now we have been described systems for the detection of group of trichotoxin producers based on sequences of rapid markers, aligned with chromosomes 1 and 3 Fusarium grimiarum sequences, because of there are only 3 species of Fusarium with whole sequence genome. And in our laboratory, we developed test PCR-based systems for the detection of plant pathogens of different types of organisms, like fungi, Fusarium insectoria, bacteria, plant viruses, potato plant viruses, and other pathogens. And also we describe control systems of potato-actin mRNA sequences for check of quality of PCR. Our group are participants in framework program 6F, 6 diagnosis, development of new and cost-effective methods and tools for diagnosis of pathogens. And also we work in 7 brand saving a modular systems platform for advanced cancer management. Here we can see publication related with theme of our work. And the next one is, you can see, the staff of our laboratory. And thank you for attention.
Good question, please. Please.
I have only a comment. Just please try to consider Fusarium boa not as a both trichotoxin type producer, since Proctor showed in his last paper on molecular microbiology that he lacks Fusarium boa lacks the gene 316, which is essential for the biosynthesis of the type of trichotoxin. So just consider this in your future research, please.
Thank you for comment. I should say that the results of mycotoxin analysis, which we used in our study, based on data of chromatography, and I should say that there is a possibility of false positive results in this study. It's possible.
Please. What? Questions? No. We thank you again for your report. The next speaker